As we have seen in the first video, it took about 30 minutes to analyze this big structure with more than 100 parts. We have found that there is a weak area in this construction, and now we will use CATOPO to find the best shape for the stiffness. For that, we model the design space first. That's the total area where we can place stiffness on. And this additional volume we add to our existing structure. We make a fine mesh on it, and now we had to define how we want to optimize it. You can see here the structure and the design space where we can place stiffness on. We define this design space with its multiple bodies as an area where to create the stiffness, and we want to have 20% of these volumes used for the stiffness. We use the load case we have defined before, and now we can start our optimization run. This is an iterative process which will take about several hours, and because we want to have a symmetry, we add the condition to have a symmetric solution. This solution can be symmetric to 1, 2, or 3 planes. In this case, we select an optimization with 2 planes for the symmetric result. We will not define any other restrictions for not to disturb the solution. Again, we start the solution in the background, and now we had to wait about 3 hours to get our solution. We will run it here on the same computer where we have done all the definitions. Again, we use the batch ability of the solver and the queuing system to start the calculation automatically on a computer. We export the data and let the calculation run. We define the amount of memory and the number of CPUs used, and the calculation starts. We import this density result, and now we can look at this result, and you can see that it is a smooth result without any external smoothing. The result is smooth from the very first beginning. Here you can see it from the back side also, and now we will use the cut function to cut away the material which is not needed. This is the blue material. The red material is needed and the blue material is not needed. And we will cut away to show the structure. And this will take a few seconds to analyze where these cutting planes, cutting surfaces work. We hide the element edges of this new created elements, and we can then better visualize the new shape we have found by our optimization run. We can now estimate how the new structure should look like. To check if this material is really enough for our stiffness, we use one of the outstanding features of CATOPO to analyze this structure immediately without any additional work. We just can use what we see on the screen This was just created a new finite element model with all load cases we have before, and now we can analyze this structure with this new shape without any additional CAD work. Again, you know this process now from the former work. We export the data and the calculation run is started automatically in the background. And a few minutes later, we have our result on the screen. And as you can see, if we would create this stiffness in the way the optimization runs found it, we would have an absolutely perfect solution. And now with this information, we go back to our CAD system and create the stiffness in a way that we can produce it and weld it to the existing structure. Here you can see the stiffness created in the CAD system, and we add this stiffness to our existing model, create the connections and start the analysis, and at the end, a few minutes later, we will have the result and see it's really the best way we could do with less material, and we will have our stiffness. So with this stiffness, our construction will work and will overcome the whole lifetime. That's the way we can analyze and optimize constructions with CATOPO.